Assalamualaikum and hello everyone. Today we are going to present about first wave of microelectronics. Here's are the group members. Fakhrurazin bin Muhammad Ali, Muhammad Adib bin Fazil, Nur Eli Natasha binti Ibrahim, Nur Ain Farhani binti Muhammad Arish, and Tan Chun Guang. These are the table of contents. First, introduction. Second, background history. Third, application. And lastly, future trends. Okay, let's start with introduction. So, about first wave microelectronics. Microelectronics is the first and the most important technology in world. Microelectronics is defined as that area of technology applied to the realization of electronic systems made of extremely small electronic parts of elements. The term microelectronics is normally associated with integrated circuits and often thought to include only integrated circuits. Microelectronics is a field in electronics that utilizes tiny or micro components to manufacture electronics. As demand for small and less expensive devices grows, the field continues to expand. The main areas of focus generally are research, reliability, and manufacturers. Semiconductor material such as silicon and graphite are the most used element in the manufacturing of microelectronic devices. These include transistors, capacitors, inductors, resistors, and diodes, as well as insulators and conductors. Okay, next I will pass to Adi to continue for background history.
Okay, next is the background history of the microelectronics in the first wave. William Bradford Shockley, John Bardeen, Walter Hauser-Brattain is the name of the inventors of the first transistor. As we know, microelectronics has revolutionized the field of electronics and is rapidly transforming our lives and our world. Microelectronics is the first and the most important technology wave. The most fundamental building block of microelectronics, also known as the transistor, was invented in 1947 by John Bardeen, Walter Brattain, and William Shockley. John Bardeen, Walter Brattain, and William Shockley has also demonstrated the point contact transistor to their co-workers at Bell Labs in New Jersey. Next, I will pass to Fakhrurazin to continue the background history.
The point contact transistor is the first form of the transistor and was made from gold foil strips pressed into contact with a slab of germanium on a plastic triangle. In 1959, development of planar transistor technology by Bob Noyce. The first IC consists of two transistors and one resistor was also developed by Jack Kilby in 1959 and received a Nobel Prize in 1972 and 2000. In 1965, Gordon Moore stated that the computing power of integrated circuits would increase exponentially along with the advancement of transistors over time, while the cost would decrease exponentially and became now known in the scientific world as Moore's law.
Okay, next is the application of first wave microelectronic. Transportation is one of the example in application of microelectronic. In transportation, we have vehicle sensor. More electronic system in vehicles such as vehicle sensor are being developed for autonomous driving technologies that enabling higher awareness and visibility. The special advanced feature in the vehicle include adaptive cruise control, park assistant, lane keep assistance, pedestrian detection, and traffic sign recognition. Based on number of the sensor located through the vehicle, autonomous vehicle create and maintain a map of their surrounding. First, ultrasonic sensor in the wheel detect curbs and other vehicles when parking. LiDAR, light detection and ranging sensor estimate distance, detect road boundaries and recognize lane marker by bouncing light pulse of the car surrounding. Next, traffic signal are detected by video cameras, which also read road sign, monitor other vehicle, and look for pedestrian. Radar sensor keep an eye on the movement of nearby cars. Next, in medical microelectronics, we have wearable sensor. First, wearable sensors are used to gather psychologists and movement data, thus enabling patients' status monitoring. Second, patient's data is transmitted to a mobile phone or an access point via wireless communication, which then transmit the information to a remote center of the internet. Lastly, sensors are also integrated into various accessories such as clothes, wristband, eyeglasses, headphone, and smartphone. This is the example of the wearable sensor that used in medical microelectronics. Next, I will pass the time.
All right, now let's proceed to the future trends. Microelectronics is undoubtedly one of the key components of today's world, and it has revolutionized our lives. Over the past 20 years, advances in microelectronics have grown exponentially in terms of device density and performance, and it shows no signs of slowing down. Next, let's look at the transistor count. Transistor count is the number of MOS transistors on an integrated circuit (IC) chip. The growth rate of the number of MOS transistors generally follows Moore's law. Observe that the number of transistors doubles approximately every 2 years. The growth rate is faster memory, easier design, and debugging due to their regular and highly repetitive structure, which is slower for logic devices, which usually require considerable design time. In the future, the number of MOS transistors may continue to increase with the years. Next, the feature size reduction driving mainly due to advances in lithography. Device miniaturization has occurred in both photonics and electronics to achieve higher speeds. The increase of die size related with the improvement in the quality of materials, first of all silicon substrates, chemicals, and vapors processing conditions. Also increase in wafer size, equipment complexity, and performance required by the facility itself allows for the low defect density required for advanced integrated circuits, which helps increase the cost of facility, which seems suspiciously close to exponential. Last but not least, if we try to extrapolate the current trend as in the next 10 to 20 years, we have two main problems to solve. First is technical limitations. Technical factors are the easiest resolved and they can be more easily quantified. The most critical issues for the future of microelectronics are lithography, transistor architecture, interconnects, and defect density. Next is cost limitation. Both will influence the future development of microelectronics. That is the end of our presentation. Thank you.